On the shortcut, what questions do we have? We want to see, go over, anything like that? 3.
Yes, maybe 4 as well.
Okay, we do 4. Except my smartboard is doing weird things, so I had to write it down. So 3, 4. Any others? 1. Mm-hmm. Or not. Okay. So 1, 3, 4. Okay. So let's start with 1. I know I saw a lot of you working on 1. Distribute. We have negative 16 minus 14x minus 21. Combine your like terms. So negative 37. Then you have options. Pick and choose what you want to move. Say I add 14x and subtract 23. What is that? Negative 60 equals 12x. Divide both sides by 12. So that x equals negative 5. So you got that? Good job. Questions on 1? Three, you may or may not remember from Algebra 1 is something that's covered in, but it's really asking you to find the domain. So your x values, where does it start and stop? So for your x values, you're looking at the furthest point to the left and the furthest point to the right. Because this has arrows, it's going to keep going slightly up and slightly left. And then same thing for the right, slightly up and slightly right. So if that's going to happen, it's going to go off the grid, off the page, forever and ever in those directions. Since it does that, the domain is going to be from negative infinity to positive infinity. It never stops. So we did this when we were doing inequalities, interval notation, so you could write it like negative infinity to infinity. When you were first taught domain and range, you probably saw it in set builder notation, so I'm going to write that up here just so you see what it looks like. They mean the same thing, but this is interval notation, this is set builder notation. This says or means x such that x is an element of all real numbers, which really just means it goes from negative infinity to positive infinity. But that would be your domain. Questions on 3? Then number 4, you have to solve this for y. So this is going back to our solving literal equations. We're trying to get y by itself, so we would subtract ax to both sides. We have by equals c minus ax. Then you're trying to get y by itself, so you would get rid of the b by dividing it to everything. Since nothing would simplify with the b, you could just divide it all at the same time. So y equals c minus ax all over b. And that would be your final answer. Questions on? Okay. 1. Take out your direct variation notes from last class, if you haven't already. And then I'm going to give you like 20 minutes to practice one of the following two things. In those notes, the last couple of pages are just practice problems. So you can be working on these practice problems on those pages, numbers 1, 3, 6, 9, 12, 13, and then on the very last page of word problems 4 and 5. Do as many of those as you can in the 20 minutes. Or, if you have not done today's Khan Academy, you can work on those. So either the Khan Academy that is due today or this, but you must be working on one of these things. Questions on that? Alright, so it is 12:48 at 1:08. We will start inverse. So you have 20 minutes from now. So everyone should have them in front of them. As we start going through these notes, you'll notice that a lot of things are similar to direct variation, which is nice. It's just some of the process is a little different. So I'm going to be comparing them a lot so that you kind of understand the difference. Okay? Where direct variation has a constant ratio, inverse variation has a constant product. Where direct variation has the equation y equals kx, inverse variation has the equation y equals k over x. When finding your constant k for direct, we use the equation k equals y over x. Here it's k equals y times x. Just like the direct variation equation, if you forget how to find k, you can use the original equation to find it. So if we take this equation and we're trying to solve for k, we would multiply both sides by x, where the x's would cancel. And whether you write y times x or x times y doesn't matter because multiplication is commutative, so the order doesn't matter. So just like direct, when finding your k value, it needs to be the same for all of your ordered pairs or values in the table. So we're going to multiply these together in number 1. And see what you get for each one. And if they're all the same, then you can say that is your k value. And once you have your k value, you can put it into your inverse variation equation, y equals 20 over x. Questions on that? Let's do one in a table. So number 3. Someone multiply negative 5 and 2.4. Tell me what you get.
Negative 12.
Okay. And then this is also negative 12 and negative 12 and negative 12. So our k value would be negative 12. So our equation would be y equals negative 12 over x. Questions? This next part, I'm going to show you how to graph an inverse variation. You're not going to need to know how to graph it, but you're going to need to be able to recognize it from a graph. So like if you got a graph, being able to see it, you would know automatically is it inverse or not. So if we were to graph this, it tells us we have a constant of 16. That means our k value is 16. So in order to get that, think of numbers that multiply to be 16. Four and 4, and then I heard 2 and 8. What else? Not 6 and 2.
1 and 16.
1 and 16. Because you were thinking 12, but that's okay. 1 and 16. And then we can also take these numbers and flip them. So 8 and 2 and 16 and 1. And we're going to graph these, plot all of these points. So the graph is counting by 2s, so be careful with that. So 4, 4, 2, 8, 1, 16, 8, 2, and 16, 1. And you get something that looks like this curve thing. Connect the dots. When we were naming numbers that multiply to be 16, we were only focused on the positives, but negative times a negative also will give us a positive, so we're going to make these negative also. So negative 1 and negative 16, negative 2 and negative 8, negative 4, negative 4, negative 8, negative 2, and negative 16, negative 1. And plot those points also. So you get like the same kind of points, but flipped. And then connect those. This is what an inverse variation function looks like when it's graphed. So if you got like an equation, if the equation matches your inverse variation format, then you know it is. But if you're not sure, or even if you want to double check, you could type it into your y equals on your calculator and see, does it do this? And if it does, then you know it's inverse. If it doesn't, you know it's not. If it's a line, you know it's definitely not. So anything that does not make this kind of shape, even if it's on the other side, if it doesn't make that shape, it's not inverse. Questions about how to recognize if we see that? If we were to see that. After you have finished graphing, move on to the next page. We're going to skip the graphing examples because we don't need to do others. Write in the two equations that we were just talking about before. Y equals k over x and k equals y times x. What's nice about this is that the process is the same. Find k, put in your equation, solve for whatever variable. That part's the same. It's just how we specifically solve is a little different. So starting with number 7, we're going to find our k value first. Multiply the numbers you have together. So 12 and 14. Someone multiply that. Tell me what you get. 168. Once you have that k value, put it into your equation. Y equals 168 over x. Look at your other set of ordered pairs. Look at what you have and don't have. So we have x, we don't have y. Put that number in for x. Divide that, tell me what you get. $168 over negative 24.
Negative 7.
And then if you want to check yourself that method is the same, look at your whatever you were given, the negative 7, multiply it by the x. So negative 7 times negative 24 should give us 168. And because we know that works, that would be our final answer. Questions on that? Negative 24. Other questions on that? Let's do another. Let's jump for 10. Because 8 and 9 are both solving for y, and I want to do one where we solve for x. So look at the ordered pair where you have both numbers. Multiply those together. Take that number, put it in your equation. So y equals negative 63 over x. Look at what you're given and what you're missing. We now have y. We don't have x. How would we solve for x? You're saying multiply negative 7 on both sides? Or negative 63 on both sides? Neither of those would help you. Bless you. Because then you would still have x in the denominator.
Would it be like
These numbers don't exist anymore. We're just going to take this. Yes. Multiply both sides by x. We have negative 7x equals negative 63. Then divide both sides by negative 7. We check it. 9 times negative 7 is negative 63, so that works. What questions do you have on that? Let's do a couple of examples with the words. Same process, just now it has words. So let's do 11. Take the numbers you have, multiply them together to find k. Take that k value, put it in your equation. So y equals negative 54 over x. Here, again, we're looking for x, and we have y, so put 3 in for y. Multiply both sides by x. And then divide both sides by 3. What would your x value be? And if we were checking that, negative 18 times 3 is negative 54, so that works. last one on this page. 14. So now multiply -8 and -7 to find k. Take that k value, put in your equation. So y equals 56 over x. Now we're looking for y and we have x. So put that in. What is your y value? If we check that, -14 times -4 should give us positive 56. The biggest thing about these is keeping the equations straight so you don't mix them up, and the process. Or I should say because the process is really the same. So more so the equations within the process. Okay. Questions on that? We're going to do a few word problems and then any questions you guys have, and then we'll be done. So at the top here you have, when do we use inverse or something? Is when one example goes up and the other goes down, or vice versa. So like, the faster you drive, the less time it takes to get somewhere, and vice versa. The more time, the slower you drive, the more time it takes to get somewhere. Same thing could be said about trains, planes, etc. I had a really good example earlier, but I don't remember what it was. But think about them as they don't move together. They don't go up and down together. They're always opposite. So let's do 7. The y and x here stay the same. So whatever comes first is still going to be your y no matter what. And then whatever comes after is still going to be your x. We're still going to have to either label them or write them off to the side, which I'll do that. So y would be our time, x would be our average speed. Here you'll see words like varies inversely, inversely proportional, things like that. So if a train travels between 2 cities in 3 hours, so that would be your time, your y, at an average speed of 65 miles per hour, your x. Same as before, focus on the numbers you have first, find your k. So 3 times 65. Multiply that, what would your k value be? 195. Here we won't have like a y per x thing because it's not the same every single time, I think. Then again, just with direct, we need to know which thing we're solving for. So if it says how long would it take at an average speed of 78, are we looking for y or for x? Are we looking for x?
Oh, no, y.
We're looking for y because we have x. Right? And I skipped this up. So let's put this in our equation. Y equals 195 over x. And then we can put in 78 for our x. Yes, what is it? 2.5 what? 2.5 what?
Miles.
That's average speed. Time. What was related to time? Hours. So that, no, I'm glad you did that because that would be a good example of something I might see that you put on the test or quiz, and then I'm like, did you know what you were solving for or not? So make sure that you label it correctly. Yes. Did you make a pass already? Okay. Questions on that? If you were to check 2.5 times 78, it should give you 195. Okay. Let's do 8. So with 8, a company that produces laptops has determined the number of laptops it can sell varies inversely to the price of a laptop. So number of laptops is your Y, price is your X. $2,000 laptops can be sold when the price is $2,500. So the 2,000 will be your number of your Y. The price we know is X. Use those numbers to find your K. It's going to be a big number. Mm-hmm. So put that in your equation. Y equals 5 million over X.
We just put 5 mil.
You can put 5 mil as long as you don't put like 5M and then forget what the M stands for. Then how many laptops can be sold if the price of the laptop is 1,000? So what are we looking for? X or Y? Y. We're looking for number of laptops because they tell us the price. So put in 1,000 for X. How many laptops do we have?
5,000.
And since we're looking for number of laptops, our label would just be laptops, not dollars. Question on that one? One more, and then any you guys want to see, and then we'll be done. So let's do 11. The time it takes to bake a turkey varies inversely with the oven temperature. What is your X? What is your Y?
Time.
Time and temperature are X and Y. Which one is which?
When is Y be time?
Mm-hmm. If it takes 3 hours, your time, your Y, to bake a turkey at 300 degrees, your X, multiply those together to find your K. And here it's asking you to find the constant of variation, which is your K value, so 900 is your answer.
Any questions on that one? Look at the problems we did not do. Are there any we want to see, go over, have questions about? We wouldn't even really put a label on it for this. If you're looking for K for inverse, you don't have a label because it's not like 900 degrees per hour or anything like that. So just leave it at 900. So as soon as Naima gets back to me. Any questions we want to see, go over? So for the remainder of class, you guys have this time to go through any practice problems we didn't do. Use the last page of practice problems, go through those. Work on the Khan Academy that is due next Friday because now you have that knowledge. So use this time wisely. Let me know if you need my help